So why does code get complex? In other words, what makes it lose those good code characteristics we spoke about?
Well, one of them is if people write hard to read code. And that can include bad or inconsistent coding style, so it's one way in one part of the file, a different way in another part of the file, and the spacing is all messed up and it's just simply hard to read. Another way it could be hard to read the code if people make up all kinds of very hard to read function or variable names. Another one if there's no comments or even API documentation. The hard-to-read code issue is fairly easy to fix. You just rewrite the code or format the code the way it's supposed to be according to some style guide. However, there's a much harder problem to address. And that is a problem that software engineering has kind of battled with for years. And that is the lack of high cohesion and low coupling. So what does high cohesion and low coupling mean? So let's take a look. High cohesion is when small pieces of functionality are strongly related to each other within some code boundary. Now, I say code boundary for a couple of reasons. One, because in some languages, the boundary that this principle usually refers to is a class. In some other languages, it's a module. In some others, it's a function. But another, perhaps more important reason is because it's really a question of what you're designing for high cohesion. You can try to design a whole module for high cohesion, or you could try to design a simple function for high cohesion. It's a question of how much you zoom in, so to speak, on some area of your code. So to say it very succinctly, high cohesion is how well does that one thing stick to doing just one thing. Now, one piece of high cohesive functionality can use other functions to achieve that. So for example, if you have one function that contains several other functions, the key component here is that all three functions are very closely related to each other. In the scope of that one function, they're trying to accomplish the same thing, just taking different tasks towards the same goal. So let's take a look at a fun example. For example, if you take a look at my daily schedule and basically map it out as a coding module, it has a whole bunch of things in it: wake up, brush teeth, caffeine, code, and so on. Now, if you take that same thing and then make the daily schedule of my Mac, of my computer, the schedule is much simpler. And if you take a look closely, you'll see that in my schedule, there's very low cohesion, and in the Mac schedule, it's very high cohesion. All it does is on, flash pretty lights, run the OS, sleep, and then it turns off. In my schedule, there are things that are conflicting with each other. You know, work and working in code at work, eating dinner, creating Coursera course, late snack with cookies, and losing weight are all very conflicting things. They don't really 100% belong to each other. So therefore, the schedule makes it a little bit more complex to deal with. Of course, it also makes it more fun to deal with as opposed to the boring computer, but computers are good at being boring, not so much human beings. So the low cohesion is what's making, our daily schedules as human being complex. On the other hand, we have this loose coupling. And loose coupling means that least possible dependency of one component on another component. Having loose coupling in software is a good thing, and it makes development much less complex because it allows you not to have to worry about the rest of the system when you're dealing with one small, loosely coupled piece of it. So to say it more succinctly, when we speak about software components, you have loose coupling in such a case in which if you change one component, you do not have to change the other. For example, if you have a shopping cart and it's working very well, and then you add another component that helps you charge credit cards. So the shopping cart calls the credit card processing component. If these two components are loosely coupled, it means that if we change how credit card processing is done, shopping cart code will not change. It will not care whatsoever how credit card processing component is working. It just needs to be able to call out to it, and the rest of the details it doesn't care about. If we take a look at an example of that in real life, for example, changing an iPhone battery is a fairly complex process as opposed to changing, let's say, an LG G5 battery. You just pop it out and pop it back in. And here's, by the iPhone battery, you have tight coupling, and therefore you have very complex things to do in order to pop it out and put a new one in. And in the case of LG G5 battery, it's loose coupling because all you have to do is press some button, it pops out the battery, and you pop the new one in. Okay, so how does this express itself in software? And for our purposes, how does this express itself in a web application software? In the second part of this lecture, we're going to take a look at a simple example that shows us these concepts.